Hello, good evening. I hope I'm audible to you. My name is Yogendra Kumar. I'm a maths teacher at askIITians. Okay, today we are going to do lecture number 2 on trigonometry. I hope you have watched my previous lecture, lecture number 1, which was about trigonometric ratios. How do we get the trigonometric ratios? What are trigonometric ratios actually? Sine, cos, tan, then cosec, secant, and cot. So these we discussed like how they come, right? How they are used, okay, in finding the in a right angle triangle. How do we make them useful, right? So now we are going to do further. I hope you remember that sine is what you remember all those topics, okay, all those 6 trigonometric ratios. Let me revise for you right now. Sine of theta is what? Opposite divided by hypotenuse. Then cos of theta is what? Base or adjacent divided by hypotenuse. Then tan of theta is what? Opposite divided by base or adjacent. Now cosec theta is what? Reciprocal of sine theta. So this is hypotenuse divided by opposite. Secant theta is what? Reciprocal of cos, which is what? Hypotenuse divided by base. And cot theta is what? Base divided by opposite, right? So this is what we have, right? You need to remember that we have these 6 trigonometric ratios, and we are going to learn more about them, right? So now if we are going to cover in this lecture finding one ratio when other ratios are given, right? Finding, okay, one of the ratio means what is the meaning of this topic? Actually, find the other ratios when one of the ratio is given. That is what it should be the written here. Specific angle values for trigonometric ratios, basically standard angle values we need to figure out, like sine 30 is how much, sine 45 is how much, sine 60 is how much. Okay, that all we are going to see. Then tan for all these, actually I mean to say, like for all these we are going to see the values. Now then after that, ratio of complementary angles we need to see, right? So let's get started. Okay, trigonometric ratios are defined as values of all trigonometric functions, okay, based on the, okay, let me show you what are they saying actually. Suppose, what is the meaning actually here? I want to take one example. Suppose it is given to me sine of theta. Sine of theta is given as 5 divided by 13, right? This is what given to me. Now they are asking, can you tell me what is cos of theta, what is tan of theta, what is cosec of theta, what is secant of theta, what is cot of theta? This is all we need to find out, right? So what we do actually when it is given to me, so what is given basically, sine is what? Opposite divided by hypotenuse. So if I make a right angle triangle here, and let's say this side, this angle is what? My theta, A, B, C. So now this is what? 5. Now this is just a ratio of the two sides. So we should ideally write down here 5k and 13k. So can I find out by BC? Can I find out by Pythagoras method, right? Because I know Pythagoras says that hypotenuse square is what? AB square plus BC square, right? We have this. So 13k square is equals to AB square, which is what? 5k square plus BC square. So BC square can be written as what? You can write down this 169k square minus 25 k square, which is 144k square. So which will give me BC as what? BC I'm going to get 12k. So this is 12 times of k. Yes. So cos theta. Now if we got this by, if this is given to me, so I can figure out all other angles. right? All other trigonometric ratios I can figure out. So this is what base upon hypotenuse. It is going to be 12k divided by 13k, which is what 12 divided by 13, because cos theta is what base upon hypotenuse. Tan theta is what 5 divided by 13. My bad. 5 divided by opposite by base it is. So that's why it will be this one. This is 13, but this is 12. Now cosec theta will be what? It is hypotenuse divided by opposite. So it is going to be 13 divided by 5. Now sec theta is going to be what? Sec theta is what? It is reciprocal of cos. So 13 divided by 12, and cot theta is what? 12 divided by 5, right? So like that it is there, right? I hope you got it. If one of the trigonometric ratio is given, then we can figure out all other trigonometric ratios, right? This is what the idea. If one of the trigonometric angle value is given, we can figure out the trigonometric ratios for all other like this one, all other trigonometric ratios we can figure out easily, right? So this is the idea. Make a triangle, write down the sides, find the third side by Pythagoras method, because Pythagoras is there to help us here, right? Okay. Yes. Now they're asking here, okay, let's do this question. Fine. For the measure measures in the figure shown below, compute sine, cos, tangent ratio of the angle, right? Now this is the angle, so this is what opposite. This is what you need to remember, opposite side. This is my adjacent side or base side, and this is what hypotenuse, right? So now sine of theta is what? Opposite side divided by hypotenuse, 35 divided by 37. Cos of theta is what? Base upon hypotenuse, base upon hypotenuse, so 12 divided by 37. Now tangent, tan of theta is what? Opposite by base, so 35 divided by 12, right? This is what we do. You need to look at this like this, okay? The side opposite to angle side is what? Opposite. So this is how you're going to apply, right? So this is how we need to do it. Now specific angle values for trigonometric ratios, right? These values are there: 0, then 1 by 2, 1 by root 2. Sine 0 degree is 0, sine 30 degrees 1 by 2, sine 45 is 1 by root 2, cos sine 60 is what? Root 3 by 2, and sine 90 is what? 1. Okay, so now how do we get these values? There might be this should be like, we should know how we get these values, right? That is what the idea. So first of all, I would like to say that there is a trick to remember these. If we can remember first row, means if we can remember the values for sine theta, then it is pretty easy to figure out the values for cos theta, because you need to just bring one here like this, okay, right? Then this here, then this here, and then 0 at the end, right? This is what we can do, right? I hope you got the idea, right? We can flip those values, right, about the middle value, so we get cos values. And tan is what? Tan theta is what? It is what? Sine theta by cos theta. We know the relation, right? Tan theta is what? Sine theta by cos theta. So we can figure out that easily, right? So let me come to this. Okay, first row, there is a trick to remember this. You can do 0 by 4 root here, 1 by 4 root here, 3 by 4, my bad, 2, 0, 1, 2, then 3 by 4 root, and then 4 by 4 root for these values. Okay, for which values I'm saying? For sine values. right? We can remember the trick. Otherwise, what is the proper method to figure out these values? Okay, so to decide 30 and 60, we take the help of equilateral triangle. A, B, C. So now as it is equilateral triangle, can I make here this perpendicular here? And we know it is what? Each angle is 60. So this angle, it is what? Median also, it acts as median also, or angle bisector. So this angle is going to be 30 and this is going to be 60. ABC is an equilateral triangle, right? So this side is A, this is A, this is A, right? All the sides are A only. So can I say this is what, how much? This is how much? A by 2. And if this point is AM, so AM also I can figure out, right? AM I can find out easily. What is AM going to be here? AM is going to be in triangle ABM. AM square, using Pythagoras, AM square is going to be AB square minus BM square. Now AB is what? A square minus BM is what? A by 2 square. So A square minus A, it is going to give you 3A square by 4, right? So AM we are getting here root 3 by 2A, right? This is what we got. AM we got root 3 by 2. So now you can see in this triangle, in triangle ABM, sine of 60 is what? AM divided by BM. Sine of 60 is what? AM divided by BM. Now AM is how much? Root 3. Oh, my bad. Okay. It is going to be not BM, AB. It is going to be AB, right? So you got it right, how we get this value, root 3 by 2, right? Now, what is sine of 30? Sine of 30, for 30, this is the opposite side, BM divided by AB, hypotenuse. So A by 2 divided by A, which is what? 1 by 2, right? I hope you got it right, 1 by 2. Now, how do we get, okay, how do we get, my bad, how do we get 45? Okay, I'm coming to that. Okay, but before that, I hope you got the idea, right? These are the values we figure out. Okay, I'll come to 0 and 1 also. How we get these values also we will understand, but before that I may be required, okay, another page to do a little bit more working here. Yes, let me take this. Okay, so we have understood how sine 30, how sine 30 is we figured out, okay, how sine 30 is half. And now we need to see, okay, we have seen sine 60 is what? Root 3 by 2. Now we want to see how sine 45 degree is what? 1 by root 2. So for this also I'll be requiring another triangle, which is what? right angle triangle. Right angle triangle, but isosceles right angle triangle here I'm taking. So this is a, this is a, now here A, B, C. Now can you tell me how much is AC going to be by Pythagoras? AC square is equals to AB square plus BC square, right? So it is what, A square plus A square, which is what, 2A square. So AC is what, root 2A. Root 2A we got. So now we can say here, okay, as it is isosceles triangle, so this angle 45, this is also 45, right? So now can I say, okay, let me stick to sine values only. I was going to find out cos value, but sine also. Let's see sine values only first. So now sine of 45 is what, AB divided by hypotenuse, right? AB divided by AC. Now AB is how much? A divided by hypotenuse is how much? Root 2A. So it is 1 by root 2. So we figured out how sine 45 is, how sine 45 is 1 by root 2, right? This is all we got. Perfect. Okay, now we want to see how how sine 0 is 0. Okay. So if I observe, if you observe here, there is a triangle I want to make which is having very tiny angle. This angle, this is the angle which is almost becoming 0, right? And imagine it is going down, still it is going down only, right? So what, sine 0 will be what, opposite side will become 0. So sine 0 is what, opposite divided by hypotenuse. So 0 by longer side, right? 0 by something is what, 0 only, right? This is how we can observe. Now how sine 90 is 1. Let's see this also. Now I need to see here for this triangle, 90 angle becomes when this is what, becoming 90, right? So what will happen in that triangle? You can observe here almost 90, right? So what will happen when I make it like this? Okay, this side will become very small, and this side, if I see here A, B, C, so when this angle tend to be 90, when uh, angle is becoming 90, AB is almost equal to AC. AB is almost equal to AC. So sine of 90 is what? Opposite divided by hypotenuse. So AB divided by AC, which is what? Almost 1. So this is how we can understand these two values, right? So I hope you got the idea how these values are coming, right? This is how we get these values, right? Now let's come to these values. Okay, now cos is what? Cos is same as sine 90, and cos 0 is what? Same as sine 90, and cos 30 is same as sine 60. So that's why these values are coming here. I said like this, right? This is what it is. So we got these values, right? Like that. Okay, so this is what we are getting. Now let's see these values. Okay, like, okay, this thing, the above table, okay, it's more clarification I'm going to give you when we do the complementary angle thing. Okay, you will understand that more here, because it is what, like, okay, let me explain you that part also here, because we can always come to this question. Or let's finish this question and then I'm coming back to those values. Okay, so sine alpha is equals to 60, beta is 30, and prove that this is what equal, right? This is one of the identity which you will be learning later on. This is one of the identity. So LHS part is what? Cos alpha plus beta. Now which is what? Cos of 60 plus 30. Cos of 90. And cos of 90 is how much? 0. Cos of 90 is what? 0. Now RHS. RHS is what? Cos alpha. Cos alpha, cos beta. Minus sin alpha, sin beta. So cos alpha is 60 here, cos 60 into cos of 30 minus sine of 60 to sine of 30. Now cos 60, if you look at the table, cos 60 is how much? 1 by 2. Cos 30 is how much? Root 3 by 2. You need to remember those standard values. Now here this is root 3 by 2 and this is 1 by 2. So what are we getting here? The value here. This is what same only, right? You can see 3 root 3 divided by 4 and root 3 divided by 4, which is 0, right? Which is equivalent to RHS. So that's how we can prove it, right? We can understand that these two values are equal, right? Okay, now you need to understand this. It is very, very important now here. Ratios of complementary angles. So what do we say here? If you look at this triangle, in this triangle, sine of 90, I bet, not 90, I want to write sine of theta. We can say here sine of theta here sine of theta is equals to sine theta in this triangle PQR, PQO, it is PQ divided by PO, right? Because for this angle, for theta, for angle theta, opposite side is PQ, and for angle alpha, opposite side is OQ, right? Like that it is. Now can you see here? Now what is here cos? Can you tell me what is cos of alpha? Cos of alpha is what? Cos is what? Base upon hypotenuse, right? So it is PQ divided by PO, because cos is what? Base upon hypotenuse, and this is what? Opposite divided by hypotenuse. But because of theta, opposite here is same as base here, right? For alpha. Now you can see from this triangle, alpha plus theta is what? 90, right? So alpha is equals to 90 minus theta. Can I write down this? So here cos of 90 minus theta is same as PQ divided by PO, means cos of 90 minus theta is equals to sine theta. This is what we want to discuss, that complementary angles plays this role here, like they becomes equal. So cos of 90 minus theta is same as sine theta. Cos of 90 minus theta is going to be same as theta, and that's what you can observe here in this table also. Cos of 90 minus 0 degree. See, sine theta is what? Sine 0 is 0. Now cos of 90 minus 0 will be what? Cos, it is going to be 0 like this here, right? Cos 90 is going to be same as sine 0. Why? Because here, okay, let me show you the example here. So if theta is 0, so, or I can take any angle 30 degree, let's say, right? So theta is 30 degree. So sine 30 is how much? Half. Now cos of 90 minus theta, which is what? cos of 60, that is also half. This is how we can see. So complementary angle, if theta is, it is the 30 degree here, so cos of 60 will be same as sine of 30, complementary angle, right? This is how we relate. So you need to remember these relations. Okay, sine 90 minus theta is same as cos theta, or cos of 90 minus theta is what, same as sine theta. Same goes with the tan and cot and tan, and secant and cosecant and cosecant and secant. So this is what proof I showed you. You have to remember these relations now, right? I hope it is clear. So now we have questions based on this. Okay, and that's all. This is what the end of the these topics. Okay, but you need to remember it, right? Okay, let's do this question. If A, B, C are the interior angles of a right angle triangle, right angled at B, then find the value of A given that. What is given to us? Tan 2A is equals to cot of A minus 30 degree. Now we know, what do we know? We know that tan of theta is same as cot 90 minus theta. We have seen just now, right? Tan of theta is same as cot of 90 minus theta. You can use other relation also. We know this. So can I change one of the angle here to other one? My bad, it is cot here. Yes. So can I write here cot of 90 minus 2a is equals to cot of a minus 30, right? If two cot of two angles are same, cotangent of two angles are same, means those angles are equal. So 90 minus 3a, 90 minus 2a is equals to a minus 30. So can I take a to this side and 30 I can bring to this side? So it is 3a is equals to 120. So a is equals to 40. So a is what? 40 degree we have, right? This is how we need to do it. Okay. There could be many questions again. You need to practice more questions to get the clarity on these all topics, and you have to remember this table, right? By the way, you might be wondering how I got how we got tan theta as 0 here. Tan theta is what? Sine theta divided by cos theta. This you need to remember. Tan theta is what? Sine by cos. So 0 by 1 is what? 0. 1 by 2 divided by root 3 by 2 is what? 1 by root 3. 1 by root 2 divided by 1 by root 2 is same as 1, right? These all you need to remember. It is 1. Root 3 by 2 and 1 by 2 is what? Root 3. 1 by 0 is not defined. You need to remember it as 1 by 0 also, but not defined also you need to remember. Now cosec is what? 1 by sine theta. Cosec theta is what? 1 by sine theta. So reciprocal of sine values we do. So 1 by 0 is what we say not defined, or it is 1 by 0 also you can remember. Now 1 by 2 reciprocal is what? 2, right? Because reciprocal of sine values. 1 by root 2 reciprocal is what? Root 2. Root 3 by 2 reciprocal is what? 2 by root 3, and 1 reciprocal is 1. Secant theta is what? Reciprocal of cos values, cos theta. So 1 by 1 is what? 1. Here 2 by root 3. Here root 3. Here 2. Right? And this is not defined. Cot is what? You can say cos by sine or 1 by tan. Right? This is what you need to remember. You can do the reciprocals again. So you have to remember this table, the standard table. Okay. I hope you got clarity on each topic here, right? So this is we are ending lecture number 2 on this chapter. You need to watch next lecture to understand the trigonometry more, right? But before going to next lecture, which will be identity based, we have to remember all these, right? You watch it again, but you have to remember, okay, these relations. Okay, these relations you need to remember it. These are very, very important. I think you got the clarity on each how we are doing. By hearting is it is like we need to remember the identities, or we need to remember these relations, but by understanding all the topics. Without understanding, if you do, it is not good at all. right? So you have to remember it. Okay, thank you very much for your time. Hope you have enjoyed it. Okay, and you have understood everything. Tune in for the next lecture, right? Join, watch that. Okay, watch that lecture, and make sure you're doing well in trigonometry. Okay, thank you very much for your time. Bye bye.